As part of the residue of scopes, we actually get what's known as garbage. And what I want to talk about now are garbage collection algorithms, which are, their purpose is, in a sense, to collect all this garbage. So let's first define what is garbage. Garbage, in a sense, is data which is allocated by the system or whatever, by the language, by the runtime, whatever, however you allocate the system, and is not reclaimed. And it's not accessible from any location on the runtime stack, and therefore it is deemed as garbage, meaning that the memory location, as far as the operating system is concerned, as far as maybe the runtime is concerned, is taken up, and it can't allocate it to anybody else, but it's actually not accessible, and therefore it's actually garbage. And when we talk about garbage, we want to talk about two different ways of actually reclaiming this garbage. Actually, two opposing ways. One is known as reference counting, which languages like Python do, and one is known as garbage collection, which is more famous, which languages like Java uses, C#. And the actual name of the entire domain that we're talking about right now is garbage collection. But when we break it down, we actually talk about two different algorithms. We're talking about reference counting and garbage collection. Okay, so there's the general name, which is known as garbage collection, and then there's the breakdown that we are actually dealing with. Now, before I actually go into the actual problem, I want to make a bunch of assumptions to make our discussion simpler. Our assumptions are going to be that memory looks the following way. We have the memory is actually broken down into these blocks of memory. Okay. And every block, in a sense, contains some data, right? Some data and a pointer to the next block. All of them look the same way, right? They're all data and pointer, data and pointer, data and pointer, right? They're all like that. And we're going to look at our entire memory as a bunch of these blocks. Now, you might think that this doesn't make sense, this assumption, so you just know that there are languages out there, like, for example, Lisp, which actually does exactly that. It looks at the entire memory as a linked list, okay? So that's our actual memory mapping. It's going to be right now, it's going to be this way. I might not draw it like this all the time. I just might draw it as just squares, but I'm actually talking about that. And we're going to have to actually, in the future, talk about what happens if it's not like that. Okay, but we're going to assume right now that this is the way memory looks. Okay, now it's very simple now. To allocate memory is actually very simple. If you have on a runtime stack and you need some memory and some pointer to some memory, so you just allocate the amount of memory you need, right? And you have what's called a free list pointer, which used to point over here. Now what you do is you point as much memory as you need. You take as many blocks as you need. Wherever you finish, you break the link, right? You break the link, you make the free list point to the first empty space, you stick here your null, right? Your null pointer, and we have our memory our memory. If you want to allocate now more memory, so we have some other pointers somewhere on the runtime stack. Again, same idea. We're going to connect it to the new empty spot. Okay, we are going to take as many boxes as we need, whatever it is. So let's say we need 3 boxes. So we break the link right there. We move the free list pointer back to the first empty one. And we again have our memory location. Notice how we're allocating memory. It's actually very simple. The question is, what happens when something goes out of scope? Suppose this guy here goes out of scope and this memory actually got freed up. How do we reclaim this memory? This is actually what's known as garbage collection. How do we reclaim the memory that's actually there? Notice that this memory that we actually have over here, right, is actually taken up, but it can't be accessed by anybody because nobody knows where it is. Now, I drew a very nice picture, but it could very well be that the memory that we actually have is actually a bit more complicated than that. It could very well be that the links actually look like this. I'm just throwing out an example. And the link here could actually go like that, right? And this becomes a null. So it's actually not easy at all to figure out, where is your empty memory? Where is it? And for that, we start talking about garbage collection. And as I said, we have two actual methods we're going to talk about. We're going to talk about reference counting, and we're going to talk about garbage collection. And we talk about garbage collection, we're going to talk about two different algorithms. We're going to talk about the mark and sweep. And we're going to talk about Cheney's algorithm. Cheney's algorithm. And both of them have their advantages and disadvantages. And we'll go into, afterwards, we'll discuss what happens in the JVM, what happens in the CLR. They don't use actually mark and sweep, they use what's known as generational mark and compact. We'll talk about that too, which is a variant of the mark and sweep. But this is the basic picture of what we're going to actually talk about.